This is lesson 4.6 on logarithms. So we've been talking about exponential functions. We've previously in our math classes before have talked about what it means to raise a number to a certain power. Even in this class we examined that problem. There were particular problems where we had to refresh ourselves about what does it mean to raise something to a rational power. Logarithms are going to be taking that exact same concept, raising some number to a power, and basically turning it on its head. We're doing an exponential type problem in reverse. So for example, if we have a logarithm, so what I've written here, we see log AB. The way that we read that is log base A of B. In order to solve log base A of B, we need to ask ourselves, okay, A raised to what power equals B? So for example, if we were told to evaluate log base 3 of 81, we would have to ask ourselves, okay, 3 to what power equals 81? So we know that 3 times 3 is 9, times 3 is 27, times 3 is 81. So we had four threes that we multiplied there. So we would say that log base 3 of 81 is 4. That's because 3 to the 4th power equals 81. So logarithms are exponential problems in reverse. Now, one thing that we need to mention, we're not going to run into this any on our drill problems, but there are two very special bases for our logarithms that we need to point out. Those two special bases, we're going to call them the natural log and the common log. When we talk about the natural log, and we're going to write that as ln of whatever number. So here we have ln of b. We read that as natural log, and natural log means that we were taking this log base e. Remember the constant e that we introduced previously? It's 2.7 something 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 something. We don't need to worry about that. Whenever we run into e, we're generally just going to leave it as e. Just like pi, it's a mathematical constant. It's infinitely long. We can't write the whole thing out, so we're just going to use e as shorthand. So natural log of b is going to be log base e of b. We don't need to rewrite it as a log base e unless we know that we get confused and need to do that. So natural log means we're taking log base e. The other frequently used log base is 10. We call this common log. Now this might look like a typo, log of b. Notice that I did not specify a base in that first statement. If we do not explicitly specify a base, we're referring to common log. That means log base 10. So if we run into a problem where the base is not specified, don't immediately freak out and think that something got left out of the problem. Almost certainly we're dealing with common log, so we're dealing with log base 10. So here's a quick and easy one. Evaluate log base 4 of 64. So once again, what this means is we need to think, okay, 4 to what power equals 64? Now if you have your powers of some of your small integers memorized, that's great, but if not, no worries. Here's how we can get through this. So just think of 4 times 4. I know that's going to be 16. 16 times 4, let's see here, 40 plus 24, so 64. So there we go. 4 times 4 times 4 is going to be 64. So that tells me then that 4 to the 3rd power is 64. So my answer then is that exponent, 3. All right, one more of these. Evaluate log base 5 of 1 over 25. So since I have the reciprocal of a power here, I know that my answer is going to be negative. Since this is between 0 and 1, and the base of my logarithm is bigger than 1, which that's not always going to be true, but most of the time that is true. That means that my answer is going to be negative. So ignore it for the time being. We just want to figure out what power of 5 is 25. Hopefully we recognize that one. We know that 5 squared is 25. So that means that 5 to the negative 2 power, that's going to be 1 over 25. So that tells us that our answer in this case is going to be negative 2.